Hello and welcome back. In this series of videos, we're developing a new sample database modeled after the one I actually use with my customer work, although it will have some significant differences by the time we're through with this sample. The first table we built was called the customer table, and that will be the central or primary table for the entire database. Everything is built around it. Features in this table of importance include the use of a surrogate primary key based on the auto number data type in Access. Each customer is uniquely identified by their customer ID. Customer ID can't be duplicated. Access will create a new value for the auto number each time you start a new record. Whether you save that record or not, once you start it, Access will not reuse that particular value that it generates there. And you can see that actually in this table here where we have a gap where I started a record and then didn't finish it, didn't save it, and it's still lost customer DBA ID number 3. So in our customer table, we started out with some sample data, and we wanted to do that for a couple of reasons. Sample data will help us figure out if what we're doing is appropriate and complete, and it also helps in this process to illustrate what we're doing. We created the customer name field, and we applied a unique index to that field. Each of these customer names must be unique. We can't have two customers of the same name in our database, and so we have a unique index enforced on that field for that reason. And then we started looking at business rules, and we recognized in talking about the kind of customers we would want to track that sometimes a customer will actually have subsidiaries or doing business as entities, the DBA. And so we needed a way to account for those DBAs for each of our customers. And our first attempt was to create what is sometimes referred to as a spreadsheet style table, and sometimes more commonly referred to as a repeating group. And repeating groups are characterized by same name, DBA in this case, and a numeric suffix or prefix which indicates this one is number 1, number 2, number 3, and so on. We quickly recognized that that was not going to be very productive for very long, because even though we started out with only 3 DBAs for Western Washington builders, chances are very good that as soon as they finish their third project, they'll start a fourth. And that means we would have to come back, add a new field to the table, and in turn modify any forms bound to that table, any queries, any reports. Everything that has to do with customers would have to be modified to account for the fact that we now have DBA 4. The other problem we recognized is that some of our customers have no DBAs. And that creates this effect of holes in the data. And we know that that's not a good thing. Just visually, that doesn't look good. And there's a good technical reason for that, and a business logic efficiency reason for that. So our next attempt to resolve that problem was to create what we called the customer DBA table. And in this table, we resolved the problem of the non-normalized version over here in customers by taking each of these DBAs and converting it from a field or column into a row. This is something we really emphasize in developing a relational database. Rows are cheap. It's easy to add a new row. Columns or fields are expensive. It is very expensive, very difficult to add new columns. Columns are expensive, rows are cheap. So at that point, where we left off, we had created this table and populated it with our 3 DBAs. And now we have resolved that first problem. But there's a new problem we're going to have to address in the next step. In addition to the customer DBA, we want to have tables to account for phone numbers, email, and location address information for each of our customers. And just as we know that a customer can have 2 or more identities, DBAs or subsidiaries, we know that customers can have 2 or more phone numbers, 2 or more email addresses, and so on. So we're going to want to have a similar strategy for each of these tables. But then we immediately run into another problem. If we try to join or create the relationship between the customer table and the phone table, we only have the 3 primary or master level customer names. We don't have separate records here to link a phone number to Rainbow Heights and a different phone number to Rainbow Crest. Okay, let's turn back to our DBA table. Here we do have different records. A customer DBA ID 1 will link our phone number to Rainbow Heights. Customer DBA ID 2 will link that a different phone number, or perhaps that same phone number, to Rainbow Crest, and so on. That solves that problem. But we now have 2 ways to join these email address and phone tables to our customers. We can do it through here or through here. We can't do it sometimes for one and sometimes for the other. Now, I have seen attempts over the years where people have said, well, I'll just do that. They'll join the records in these child tables to one parent table or a different parent table, depending on what they're working with. And that quickly becomes a nightmare to manage. So I'm not even going to go there. We're just going to avoid that problem. So another way to deal with this might be to say, well, if we want to break it out with the customer DBA ID, why don't we take each of our primary or main or parent customers and add them to the DBA table. Let's make this a little bit bigger so we can see that whole thing. We'll do that, and then we'll say, okay, this customer DBA links back to that customer. This one links back to that customer, and this one links back to that customer. So now we have a way to attach phone, email, and address information to each of these customers independently of the others. And even though we wouldn't necessarily think of the customer DBA as the same thing as the customer, that solves that problem. It comes at a cost. It comes at a cost. That cost is we now have duplicated data in 2 places. I don't like to see that. One of the principles that I stated early on in an earlier video was that there is a place for everything, and everything belongs in its place. We don't want to have Bob's Dry Cleaners in 2 places. It's okay to have foreign and primary key relating to tables, but we don't want to duplicate data values in 2 or more places. So now we got another little problem. We're looking at this going, I don't like this design for that reason. These three are not duplicated. Actually, now that I say that, I probably should make this a little more clear. I'm going to hide these fields. And that is a closer illustration to what we'll end up with at the end, because once we have resolved this relationship into the child table, we no longer need those repeating group fields, so we'll just hide them for now, and later we can come back and delete them. But now it's easier to see that these three are not redundant. These three are. How am I going to fix that? We're ready to move on with the resolution to this newest difficulty. I recognize that I'm carrying the same values here and here. But this is, in fact, related to the customer ID. This is, in fact, the DBA for customer 1. This is the DBA for customer 2. This is the DBA for customer 3. I can, at this point, replace the text value with a second copy of the customer ID, and then I can say this is both the customer relating to this name, but it's also the DBA for that customer or the DBA for a different customer. I can manage that at the table level by adding a new field. Before I do that, I'm going to say this is the DBA for customer ID. And this will be my customer ID. And when I finish this, we can talk a little bit about what we're doing and why. Okay, by changing this name to DBA for customer ID, I'm saying that this number in this foreign key field that we had before relates back to the parent DBA. This one will replace the customer DBA name with the appropriate customer ID, and it will also be a foreign key for the sake of clarity. Now, I'm going to go ahead and do something a little bit off subject for a second. When I know that I'm eventually going to remove a field like this, I'm going to get rid of customer ID, but I'm not quite ready to do that. I often prefix Z underscore to that name, and that tells me when I'm cleaning up, getting ready to deploy, that this is a field which will eventually go away, and I will delete it as the last step. So now, let me see here, did I do that? Yes, I did. Oh, I wanted to put this earlier. So now, let's just review what we know. Rainbow Heights LLC is the DBA for customer 2, but it doesn't have a customer ID. Rainbow Crest the same, Rainbow Ridge does. Grover Park Consulting is the DBA for Grover Park Consulting. So I can say that's 1, that's 2, and that's 3. So now my new table structure tells me this is the DBA for this customer. And it is also linked to that customer as the text value. In other words, instead of repeating Grover Park Consulting here, I'm going to say, we'll get that information here. The same here and the same here. Instead of repeating these text values each time, I'm simply going to say, if you need to know who that belongs to, go back and look at the customer table. That works for these three, but now I've created yet another problem for myself. And that is, I can't relate these to a particular customer. I don't have a customer. As you may have guessed already, the solution to that is I will put them in as customers in their own right. And now I do have a way to say this is customer 4, 5, and 6. So instead of having duplicated customer name in two places, I simply, and again, I will later delete. For now, I'm just going to hide. So each of my customer DBA IDs relates a customer, and that gives me the customer name, and the DBA, and that gives me the parent, or the master level customer. Each of these DBAs now relates back to one customer in the customer table, and it also indicates who that DBA belongs to. The same thing could be done with subsidiaries or franchises or multiple retail locations. Anywhere that you have a master entity, Shopco Incorporated, with stores on 3 different streets, you can use the same structure to indicate the customer and all of their subsidiary locations. Franchises would be the same thing. Anything that you have that kind of hierarchical structure can be dealt with this way. And now, instead of having duplicate redundant values, we have simply foreign keys. We're almost done. I'm looking at this table and I'm thinking, you know what? This customer ID and this customer ID are essentially the same thing. Why do I have to do this in 2 separate tables? Why can't I do this same thing in one table? Can I merge customer DBA back to customer? And the answer, of course, is yes, I can do that. And this will be my final revision to this table. I'm going to flip the design view again. Open it up. That's the one I want. Flip this one into design view. Open it up. So what I'm going to do is take this field from this table and put it here. And I'll move it up into location. And I'll repeat my little trick here. I'll put the Z underscore in front of these fields, which will eventually be deleted so that they're hidden and not cluttering up our display, and they're not lost in case I need them later. So now this one will be a what I call a self-join foreign key. Now I don't know that that's a standard name you'll run across in the literature, but for the sake of our discussion, I'm going to call it that. So now we save the table, and we have a way to relate each of these DBAs, Rainbow Heights, Rainbow Crest, to its parent directly in the same table. This is number 2. So Rainbow Heights LLC is a DBA for 2. Rainbow Crest 2, Rainbow Ridge 2. Go back, compare it to here. See the same thing happening here. 4, 5, and 6 belong to 2. 1 belongs to 1. 2 belongs to 2. 3 belongs to 3. So now this entire table becomes redundant. And I can, in fact, delete it. I'm not going to do that right now. Rather, I'm going to make it a Z table. And I'll go ahead and hide it. And now I have my final table revision for customers, in which I am able to handle this hierarchical parent-child, subsidiary to corporate, franchise to location kind of relationship that would be applicable in lots of different situations, and not just customer names. Anywhere where you have that kind of hierarchical relationship, you can do the same thing. In fact, we can go one step further and say Rainbow Ridge actually didn't get completed in one phase. It took 2 phases. So we'll say Rainbow Ridge phase 1 and Rainbow Ridge phase 2. Both of these belong to the Rainbow Ridge LLC. And I'll take the LLC off it so that we're not too confusing there. So Rainbow Ridge phase 1 belongs to that one, Rainbow Ridge LLC, and Rainbow Ridge phase 2 also belongs to that. So now we have a 3-level hierarchy, and this same structure allows us to accommodate that very easily. And in fact, we can go as many levels deep as we need with this very straightforward table structure. That's it for now. In our next video, we'll continue on to create the new phone, email, and address tables. We'll address each of those individually, and we'll also talk about some of the complications you might encounter in enforcing business rules through properly designed tables in the next step. If you like what you've seen so far, please subscribe and please come back. Thank you.